Good afternoon to one and all. I am R.V. Kiran, Assistant Professor, Department of Mechanical Engineering. Today in this video lecture, I am going to explain you about two topics in the measurement of effective diameter. That is the best wire size method and the one wire method. So in the previous lecture, I have listed the two topics where I have described the two wire method and the three wire method. So in university board exams, if there is a case, they will ask these two methods also, that is one wire method and the best wire size method. So these are the measurements based on the effective diameter of the screw thread measurement. So when we are going to measure the screw thread measurement, that is of effective diameter, you need to take these two methods also in consideration, with the two wire method and the three wire method. So first one, we go to the best wire size method. So in the best wire size method, if the size of the wire contacts the flanks at the pitch line, so if it is going to contact the flanks at the pitch line, it is called as the best wire size method determined by the geometry of screw thread. So it is called the best wire size, that is best size wire determined to the geometry of screw thread. So in the picture you can see the size of the wire which is directly contact with the flank of the tooth. That is, we have two flanks here. So this is the one flank and this is the other flank of the tooth at the pitch line. So if it touches the directly the flank of the pitch line, it is considered to be as the best sized wire determined by the geometry of the screw thread. So it is determined by the geometry of the screw thread. Here, consider to the two methods, that is in the two wire method as well as the three wire method. This is considered to be the pitch line. So this is the pitch line in which it has 3 points, that is B, A and P. These are the 3 points in which we have the pitch line condition, and we have the OB and OP as the diameter of the circles. So OB and OP as the diameter of the circles, and theta is the angle in which we have to measure of the screw thread, in which we have going to screw thread. So the pitching condition from the center of the wire is taken as P by 2, that is pitch divided by the 2 condition, and the length from the center of the line to the P point, that is the pitch line point on the right side, it is taken as P by 4 condition. So that is the P by 4 point. the angle has been taken as theta by 2. So that is taken as the theta by 2 condition. Then from the pitch line, the effective diameter is taken as capital E. So the diameter has been taken as that is the effective diameter is capital E. Then it is taken as the divided portion from the circle of the point. So you need to take the half of the thread angle, that is theta by 2. So the theta by 2 is taken as the half of the threaded angle of the portion. Then from the triangle OAP, so we can take OAP and OAB also. I'm taking the triangle OAP. Sin and sin POA is taken as, that is sin POA is taken as, this is POA. So POA, that is AP by OP, that is so adjacent side by hypotenuse. We get taken as adjacent side by hypotenuse. Then we may take it also as sin 90 minus theta by 2 is equal to AP by OP. That is theta by 2 is the half threaded angle of the portion. Then we have to take the OP, that is the hypotenuse, is equal to AP by sin 90 degrees minus theta by 2. Then we used to take as AP by cos theta by 2, that is AP into secant theta by 2. So the whole can be taken as AP into secant theta by 2. Then OP is equal to R. So we can take it as OP is the radius of the wire. So it can also be taken as the radius, that is equal to OP is equal to R, that is equal to AP into secant theta by 2. Then the wire diameter is taken as the 2R. So the wire diameter is taken as 2R condition. Then the best wire diameter is taken as, that is dp is equal to 2R. So best wire size is taken as db is equal to 2R, that is 2 into AP into secant theta by 2. So it is taken as 2 into AP into secant theta by 2. So that is the value for the wire diameter, that is the best wire diameter. So here we can see the P by 4 condition and P by 2 condition. So you have to apply it both ones. So then we have to take the into the both ends. So next, since AP lies on the pitch line, so it lies on the pitch line condition. Therefore, AP is equal to P by 4. So it is taken as P by 4 condition. That is, this is the AP line, and this length has been taken as P by 4 condition. Then the best wire size diameter, that is best wire diameter, is taken as dB, that is P by 2 into secant theta by 2. P by 2 to secant theta by 2 is the formula we have done for the best wire size. So it is taken as P by 2 into secant theta by 2. So that is the best wire size of any given diameter. Next, we have to take the diameter of the best wire size. So the best size wire to be selected as recommended in the international standard limit, that is 6311. So that is the international standard condition 6311. So you have to follow that standard. Then p value can be calculated from the following formula. So the p value has been taken from the following formula, that is p is equal to 0.86602 into p. P is the pitch condition. So you have to take the pitch condition of the then P is equal to 96059. So these are the two conditions, two types of conditions for two pitch values, that is P is equal to 1.16568 into capital small d. So here P is taken as the pitch diameter and small d is equal to mean diameter of the wires used. So these are the two values for the pitch condition of the best size wire. So D is the mean diameter of the wires which you have used. Then that has to be calculated for the diameter of best wire size. You have to take these elements regarding to the pitch condition and the mean diameter of the wire used. So you have to check the wires also, that is diameter of the best size wire. So that is of the best wire size method. Regarding to the measurement of effective diameter, when we have to take the effective diameter by using the one wire method, So this is one of the best methods in taking the measurement of effective diameter for the screw thread measurement. So you can see it in the picture also. We are going to take only one wire. So regarding to the wire size method, we are going to take the only one wire. But in the two wire method and the three wire method, we are going to take multiple wires based on the measurement. So in the picture, you can see the one wire is attached to at the top end, and micrometer anvils are fixed to the other end of the screw thread. And on one side it is the wire which is attached to the micrometer anvils for the support. Then we have to take the effective diameter as D2, that is D2 as the effective diameter because there is only one wire has to be measured. Then it is taken as D plus or minus D1 minus D2. That is the formula for obtaining the effective diameter by using the one wire method, that is D plus or minus D1 minus D2, where capital D is taken as the size of the setting gauge. So it is to be taken as the size of the setting gauge. Then actual measurement over the one wire, that is over wire on one side and threads on the other side has to be taken. So that is to be applied for the measurement of the case. Then we have to take the other angle as the D1, that is a negligible one. So when we have to take the measurement of external fluid elements, so that is one wire method. So our method is the one wire method. So in this one wire method, you have to take the standard gauge. So you have to take the standard gauge for the measurement. So this method is used if a standard gauge of the same dimension as the theoretical value. So theoretical value of the dimension of the wire is available. That is the actual diameter is available in that. So actual diameter is whenever it is available, you have to take the actual diameter. Then first of all, the micrometer anvils are set over the standard gauge and the dimension is noted down. So then the dimension has to be noted down there, and thereafter the screw to be inspected is held either in the hand or in a fixture. So this has to be fixed or to be inspected. So that is the only element. Next, then the micrometer anvils are set to over the wire. So in which only one wire is taken in that. So you can see it in the picture also. This is the micrometer anvil which is fixed over the one wire. So these are the elements to be taken. Next, you have to take the micrometer readings at 2 or 3 locations. So you can take up to 3 points, that is 3 locations on different value on different locations, and the average value is taken in consideration. So you have to take the average value, not the best value. So you have to only take the average value only. And this value is compared with the value obtained with the strain gauge. So then that value it has to be compared to the original theoretical value. So that value has to be compared to the original theoretical value, which is obtained from the strain gauge. So that is obtained from the strain gauge, and the resulting difference is a reflection of error in the effective diameter of the. So it leads to the some difference between the original diameter of the screw. And here, an important point to be kept in mind is that the diameter of the wire selected should be such that it makes contact with the screw along the point of the cylinder, that is the tip cylinder. So we have to take the condition as a fixed cylinder. Then the significance of this condition will become obvious in the two-way method explaining in the next section. So we have already discussed about the two-way method, which we have discussed in the earlier classes. So the significance of the condition of the single wire or multiple wire has been discussed in that. And here capital D is the size of the setting gauge and D1 is the micrometer reading over the standard gauge. Then D2 is the micrometer reading over the thread under test. So here we have to take the only thread, that is single wire thread. Then the effective diameter is taken as, that is effective diameter is equal to capital D plus or minus D1 minus D2. So it is taken as capital D plus or minus D1 minus D2. Then if D2 is greater than D1, so here we have taken the plus or minus sign, and if D2 is greater than the D1, we are going to use the positive sign, and if D2 is less than D1, we are going to take the negative sign. So we are going to take the negative sign there. So there are the two conditions. If D2 is greater than D1, we are going to use the positive sign, and D2 is less than D1, use the negative sign. So that is the two conditions for that in the case of plus or minus negative sign. So this is of the one wire method. So in case we have taken the two wire method also. So two wire method also have been discussed in the earlier classes. So in case of two wire method, we have taken the two wires. So that is taken off two wires in this section. In case of one, their pitch is taken as P by 2 in both the condition, and we have to determine the two sections of the diameters, that is D1 and D2. We have to take the both conditions there. So that is of two-wire method. So in the two-wire method, the formula has been taken like this. Next, we are going to see three methods. So these three-wire method has already been explained. So in this, one wire is kept in the top layer and two wires in the bottom threads. So the wire diameter is taken as the wire of the so in the three wire you can take the three wires. So that is of different segment. The formula is obtained as capital E is equal to cot theta. So we will define two or three functions. So these are the difference between one wire method and the two wire method and three wire method. So we have seen all the methods considering to the effective diameter. So by there, I am going to end this class. Thank you.